Okay, so we're going to talk about why some volcanoes explode. You want to get all the materials that are listed down below here and where you see it. Okay, so we're going to start. Here we go. Oh, whoops. Guess it doesn't start over.
Hi, it's Doug. I want to tell you a true story, an event that took place on May 18th, 1980, in the state of Washington, the northwest corner of the United States. People were going about their morning as usual, when suddenly the ground shook. There'd been a huge explosion. When people looked up, they saw a cloud of smoke, steam, and ash rising up into the sky. It was Mount St. Helens. Mount St. Helens, the local volcano, had erupted its first eruption in over 100 years. When all the dust finally settled, people realized just what an enormous eruption this had been. This is what Mount St. Helens looked like before it erupted. And this is what it looked like afterwards. This volcano had exploded. It blew off its entire top. It exploded with so much force that it knocked down entire forests that had been growing on the mountainside. Cars parked nearby were buried in bits of rock or ash. In fact, ash from the explosion burst outward so far that some of it came down over 1,000 miles away in Oklahoma, halfway across the United States. Other volcanoes have erupted like this too. Here's a video from space by astronauts as they passed over Mount Sarychev in Russia, which you can see is exploding just like Mount St. Helens did. Maybe the most famous exploding volcano of all time was Mount Vesuvius, which when it exploded 2,000 years ago, buried the ancient Roman city of Pompeii. This is just a painting since they didn't have cameras back then. Now, definitely not all volcanoes explode like this when they erupt. There's another second kind of volcano, which is much gentler. Here you're seeing one. This is in Hawaii, where people are actually walking around on it. You can go right up to the lava flows in these places. Watch as this man plays with the lava on this volcano. Isn't that wild? And obviously, you don't want to get any of this stuff on you. It's really hot. And you don't want to stand too close to the center of the volcano. That'd be bad. But even if this kind of volcano were spurting out its lava, like you see here, as long as you stay out of the way of the lava, you can stand there and watch this. What's going on here? Why are some volcanoes more gentle, where people can get close to them while they erupt, but other volcanoes are explosive, blowing bits of rock high up into the sky? That's weird. Why do some volcanoes explode? To find out, we need to spend a little time looking more closely at these two kinds of volcanoes. See what you notice about them.
Okay, it says here are some examples of each kind of volcano. What do you notice about the shape? Okay, so what do you notice about this shape, Harvey? Ah, so he said the ones that kind of come up into this cone shape, you think explode? And these ones right here that are not so, that they're more the gentle. Any other observations? Yes? No? Okay. All right. So the kinds that explode, you can see that they come up into these cone shapes. Kinds that don't, they almost look just like what? Okay, like a hill or just a small mountain, right? Okay, the kinds of rocks that come out when, what do you notice that's the difference? Yes. Okay, so she says the kinds that explode are lighter, maybe, than that doesn't. What else do you see that there's differences? Where else do you see differences? Yes, Harvey. Okay, so he said that this is more the rock and the ash. Why would you say that that's more ash? Why do you think? Why would he say that's more ash maybe? than this. Yes. The colors are different. Now, I don't know if that's the case, but there definitely is a difference in the colors of the ones that explode and the ones that don't explode. Good.
So did you spot any differences in how the two volcanoes look? Hopefully you're able to notice that the exploding kind of volcano, well, at least before it explodes, it's shaped like this, like a tall cone. So let's call these the cone volcanoes. But what about the shape of the other kind of volcano, the kind that doesn't explode, the more gentle erupting? Notice how these volcanoes tend to be wide, but not as tall. Scientists call these shield volcanoes because one of the first ones ever discovered was noticed by the Vikings in Iceland, who thought that it looked like the shape of one of their battle shields when set down on the ground. Personally, they remind me more of the top of an umbrella, but we'll go with the word shield because that's the word that scientists use. There was a second difference you noticed between these two volcanoes, and that's how their rocks look. The rocks of the cone volcano, the kind that explodes, are all pale or light colored, like pale pink or pale tan. Scientists call these pale colored rocks felsite. But the rocks that come from the shield volcano, the kind that doesn't explode, are all dark colored, dark gray or black. Scientists call these dark colored rocks basalt. So we still don't know why one kind of volcano explodes and the other one erupts gently. But we do know that the two volcanoes each have their own shape and each have their own kind of rock. That brings us to a really big clue. It turns out that the reason for the two different rocks are because these volcanoes actually are erupting two different kinds of lava. One of the lavas looks like this. It moves pretty quickly because it's thin and runny. It's kind of like syrup or honey in how it flows. A couple of scientists in New York recently made a device where they can take some of the rocks from the thin, runny kind of lava and melt them, turning the rocks back to lava again. This is what it looks like. They pour it out and they observe it up close. And they can do all this without having to travel to a volcano. You see how thin and runny this stuff is? But now the other kind of lava is like this. It's thick and pasty. It might shoot out steam and fire. You can see this is a video taken at nighttime. But you notice how the lava itself just sort of sits there? It has the thickness of a material like toothpaste or peanut butter. It doesn't flow or move much at all. So which lava belongs to which type of volcano? Does the cone volcano erupt thin, runny lava or thick, pasty lava? And could the differences between these two kinds of lavas explain the differences we've been seeing between the two kinds of volcanoes? Today, you're going to do an experiment to figure out the answer to that question yourself.
Okay, so we are going to do this experiment to see if we can figure out which type of lava comes out of which type of volcano. Okay? So for those of you at home, pause this video and make yourself, this is just water and flour, make it kind of pasty, kind of like a little bit thicker than when you'd make for pancakes, and then we just have water.
In today's activity, you're going to experiment with two different liquids, one that's thin and runny, and one that's thick and pasty, just like the two different kinds of lava, one that's thin and one that's thick. In today's experiment, you're going to figure out, do the two kinds of lava explain why there are two kinds of volcano? Okay, it's time to get started. I'll walk you through the activity step by step.
Okay, it's going to tell
Find a partner to work with.
but we're not going
When you're done with this step, click the arrow on the right.
Okay.
Cover your workspace with newspaper or plastic.
Okay, so before we get started, any predictions on which one you think belongs to which? What do you think, Lee? Ah, so he says he thinks the thin water is what we're using, right? He thinks that's coming out of a shield because that's why it comes down at a hard angle. So then you think that the thicker is probably your, well, so is it shield? Which one's the cone? It's the cone or the shield, right? You think it's the shield is the water? So it comes out slower. Okay, anyone have any other predictions? No? All right.
Get your supplies. The two of you need these.
Okay, so you should have your supplies in front of you, right? Sorry, I made one less. Okay, so you should have a water and some with flour, right? You should have a straw. You should have a plate. You should have your paper that says lava experiment. Now on the back, you're going to rip it apart, okay? And one side says thick, one side says thin. So this is for you to place down and put the thick on one. See how it looks like your cups can just sit right in those circles? So you're going to put your thick and your thin on your papers. And you're going to use your straw as really your spoon, okay?
Tilt each cup to see which lava is thin and which is thick. Put them on the placemat to remember which is which.
Okay, so you want to tilt, see how it moves. Okay, this also goes along with what you'll learn in Mrs. Bishop's next time about the 3 states of liquid, right? This liquid, and this is probably more of a, is thick, right? Okay.
Time to experiment. Do your lava worksheets. When the class is done, clean up and then discuss the question on the next slide.
All right, so we're going to do the experiment here. And I'm recording this, so for those that maybe, and mine's a little, I think mine's a little thicker than yours, right? I'm going to put just a little bit more water in it. Mine's still a little thicker. Okay, so again, this is just flour and water, so most everybody at home should have these ingredients, right, to mix up. Okay, let's look at the experiment. We've got 3 bubbles. Leah, really loud. Okay, so it says stir each sample with your straw, then blow bubbles in each cup. Note, bubbles in the thick lava may not look like bubbles you're used to. Watch for craters when they burst through the surface. Okay, so you're going to, I would probably start with the water first, because once you put it into the flour mixture and then go back into the water, your water is going to get dirty. Now, this is not a contest to see who can blow the highest bubble or break the biggest head. If you can't do it how you're supposed to, then we'll just take it away and you'll have to watch someone from afar, okay? So we're not trying to get any of this out of our cups at all, okay? Okay, so I want you to experiment. Start with your water first, blow some bubbles in there. Then you can start with your flour mixture, noticing how the bubbles form. Sounds like a mad scientist lab in here right now. Okay, you're observing what the bubbles do and how they form. Okay, now watch in this liquid. Oh. let's look at the questions. Which lava is easiest to blow bubbles in? What'd you find? Which one's the easiest? Once you're done blowing bubbles, put your mask back on, please. The water in, so is that the thin lava or is that the thick lava? The thin lava, good. Okay, see if you can blow just one bubble in each cup. Yeah, you're going to have to go back and just try and get as much of the mixture off and kind of blow it out. Okay, see if you can blow just one bubble in each mixture. So you just want one bubble to appear. Oh, I heard someone just pop one. Oh, good. Hey, can you do it in lava? Yes? Okay. So it says, explain, why can you only barely do it in the thin lava? It's thin and lots of bubbles want to form, right? Even with just one breath, lots of bubbles want to form. Okay, so you need to take a minute and write, explain why it was hard, why you can do it, but barely in the thin lava. Oh. Okay, let's do it with, see if you can blow one bubble in the thick lava. Okay, go ahead and try and blow one bubble in the thick lava. Okay, let's ask the question, can you do it in the thick lava? Yes, I heard someone say it's much easier, right? Okay, if you were pushing that much breath into the thin lava, would you just get that one plop? Did you see how it kind of went plop, plop, right? Okay, so take a minute, answer, and explain why. Okay, the next question says, how are the bubbles different in the different lavas? Okay, so here is in the thin. Okay, and here is in the thick. Okay, so tell me, what about the bubbles in the thin lava? Describe them to me. They rise, okay? So you see a bubble actually form, right? What else do you notice? They form and they pop. Good. So they rise, they form, they pop. Hey, tell me about the bubbles in the thick lava then. Oh, so they don't look like the bubbles that you did when you were little and your mom would blow bubbles and you'd pop them, right? Okay, so it's the bubbles forming, where do you think? Underneath, and then it pops and just opens, right? More like a crater, right? Okay, so there's the difference in the bubbles. Okay, now you have to be very, very careful on this X. Okay, you're doing it on your plate. Okay, I don't have a spoon, so you're just going to do a little bit on it. It says with your partner, but we're not doing it with partners, we're doing it ourselves. Put 1 spoonful of the thin lava on the plate. Okay, so about 1 spoonful looks like that. Okay, it says, draw a picture in the box showing how tall it turned out. Okay, how tall did it turn out? Draw a picture of what it looks like. Oh, it's starting to move, starting to break. You must have broke the surface of it then. Oops. Okay, then it says repeat with the thick. So you might have to have a little bit, use your spoon to kind of, and you're going to put 1 spoonful of that. Now, if it was really thick, you probably could get what? It to look a little bit what? Oh, yeah, it would probably, but out of these two, which one is growing? Which one's larger? The thick, right? Okay, draw yourself a picture. Okay, those of you at home, you're going to continue. You need to click on the assignment and it's in Google on a Google slide. So you need to answer the questions and submit it.